Okay, so let's start. So thank you everyone. Thanks everyone for tuning in today. So good morning or good afternoon, depending on where you're joining. So my name is Adrian. I'm a sales manager working here at Containers. And I will lead this webinar with my colleague Kevin. Kevin is a developer advocate based in the US, and also with Michael, who is a solution architect and the Traefik maintainer, also based in France, in Europe. So we are really excited about this virtual event in order to share with you some sort about our Traefik and Swarm are a great match together to solve some of the networking challenges you may have. So don't hesitate to raise any questions you may have during the presentation. The presentation will be approximately 40 minutes long. So, and we'll keep 5 to 10 minutes for the Q&A at the end. So what are we covering today? So we are first going to explain what are the pain points associated with the containerization by running some Docker Swarm applications, and we will then explain you how you can tackle these challenges using such solutions like Traefik Enterprise. And finally, don't worry, it's going to be a very important part of the demo of the session, but Michael will run a demo where he's going to install an application on a Docker Enterprise cluster, both on Swarm and on Kubernetes inside this Docker Enterprise cluster. And we will do some canary, we will deploy some middlewares also, and you will see how easy Traefik Enterprise is. So what are some of the networking challenges associated with running some applications in Docker Swarm? So these are some sentence and quotes we captured from our users and customers when doing some discovery calls or fixing some problems together, and we thought it might be a great way to introduce the topic. So for example, every time I'm publishing a service, I need to do it twice. So here the user meant that they need to add some Docker labels in order to to push their containers on production, but also they need to go back at the proxy level to fix something. So either restarting the proxy, or attaching the containers to the right overlay network, or it can be anything, but they have the impression to do the work twice. What can I tell you also? So for example, the load balancer needs to restart to discover and expose new services. So this one is a very important piece of information for you. When you are using existing solutions such as Nginx or Interlog, a restart is needed in order to catch new services and to expose them. So this is very important. Whereas with other solutions that we will see in a second, no restart is needed. Also, some users are complaining because they don't have enough visibility on their backends. For example, it could be the IP addresses of the containers. Also, an easy way to export logs, traces, and metrics. And we will also show you how you can do that out of the box. And also recently, I got this request from a customer upgrading from UCP2 to UCP3, the Docker Universal Control Plane, for those who don't know the acronym. And unfortunately, Interlog does not allow more than one route per service. And this is something that some users would like to do, being able to route some requests from two different subdomains into the same containers, but for example, using different entry points. And this is absolutely possible, with what we're going to show you in a second. And finally, also, this webinar is obviously focused on Swarm, but we will explain you, or you can, easily, let's say, replicate what you've done with Traefik inside Swarm in Kubernetes. Okay, so and this is, because Traefik is a cloud, solution agnostic, so you can run it on different platforms. So Kevin, I'm handing over to you to present how we are going to tackle these different topics using Traefik.
Thank you for sharing with us some stories of our customers and some of the problems that they've had. I think that the main thing that we want to take away from that is that whenever you're adopting cloud native technologies and you're trying to implement a load balancer in general, you're going to run into a lot of limitations and constraints that there may not be any clear answer towards. So I want to go over what some of the features of Traefik and Traefik Enterprise are, and also how we solve some of those constraints. So I'm going to start off by going over some fundamentals behind networking technology. I'm assuming that most of the attendees at this webinar already know these things, so I'll try and be brief about them. But load balancers and reverse proxies generally serve as a programmable rules engine that route requests to specific services or backends. Now, these typically will operate at the OSI layer 4 or layer 7, depending on the type of traffic you're routing, and they're generally responsible for keeping track of which services are running, how they can be reached, and then routing the traffic to them when incoming requests match a predefined rule. Now, since they are responsible for ensuring that the components are available and that the policies are adhered to prior to routing those requests, that means it's critical for your load balancer to always be up to date, available, and reliable, as it's essentially the gateway to all of your services that are operating downstream. Now, a key component in that availability of the load balancer is that it can automatically discover and expose the services that it's responsible for routing. Now, Traefik and Traefik Enterprise not only has a flexible routing engine, but it can dynamically generate and update its configuration on the fly. And it does this through several different configuration providers. And the one that we're going to be focusing mostly on today is Docker labels. And those can be defined, updated, and configured when you actually deploy that service. So as your environment becomes more dynamic, and what this means is things are changing a lot, this generally applies to microservice environments. Restarting proxies is just going to add or update a service. It will become unmanageable, or rather, like anytime you change a microservice or add one, it just becomes a headache because you have to go back to that proxy and restart. And Adrian touched on that already. So ensuring that your services are available 24/7 is pretty important to us, which is why we designed Traefik Enterprise for resilience and to operate without that need to restart. Now, this is accomplished by subscribing to the event stream or polling for configuration changes periodically. And that means that operators won't need to restart or send a configuration reload signal at all. It just works automatically. And while upgrading Traefik does require a restart, those are done in a rolling manner, which ensures that your service remains available during that upgrade. Now another important aspect of managing a proxy is understanding the performance and the behaviors of the load balancer. Now, since reverse proxies are such a critical aspect of that operation, they shouldn't be a black box. You should be able to see into them. And Traefik Enterprise exposes metrics, traces, and logs in many different and popular formats just right out of the box. And this can include things like Prometheus, StatsD, Datadog, Jaeger, Elastic, and all of these enable operators to understand how not only their proxy is performing, but also it provides insights into the performance of the applications it's serving as well. Now, once you have a reliable and dynamic solution to handle those incoming connections, you're going to need a router which can offer your developers the flexibility to deal with those complex requirements that come with operating applications in a cloud-native environment. Now, this does include the ability to route based on a combination of subset of host names, subdomains, headers, path prefixes, including the ability to strip and append to those prefixes depending on the conditions in which those requests came in. Furthermore, developers should be empowered to abstract concerns such as IP filtering, circuit breaking, and rate limiting out of their applications and manage them via dynamic configuration through the Docker labels, which frees them up to work on solving actual business problems rather than trying to manage traffic at the application layer. Now, those same management capabilities, we like to extend them to how the traffic is managed as well. Now, the same approach that is used to configure where the request is routed through those labels can also be used to manage how the traffic is routed. So that means that capabilities that were once thought to be available only running in advanced orchestrators, maybe like Kubernetes, can be leveraged in Swarm. One of those capabilities is canary testing, and Michael will demonstrate that here in a moment, which allows operators to send a specific weight or a percentage of traffic to 2 or more versions of a service. And this can be utilized to test changes to applications without affecting a large subset of your users. Now, in addition to the traffic routing and management features, Traefik Enterprise offers advanced authentication middleware, again, freeing your developers from having to manage complex integrations with third parties, their authentication providers within those applications, because this becomes even more laborious as the number of frameworks and languages in your organization grows. For example, if you're trying to manage authentication in a Node.js app, and then a Java app and a Go app, the way that you manage that is going to be completely different because frameworks and languages differ so wildly. So the mission behind Traefik, outside of providing operators the ability to configure and route their traffic, is also to manage it. And we don't want managing those concerns to be difficult, which is why Traefik Enterprise offers centralized tooling and dashboards to ease the administrative burden of ensuring those applications remain accessible and reliable. Now, you'll see here shortly in the demo by Michael how the command line tools and the dashboard delivers that manageability, and how we have a large catalog of middleware that exists already on the shelf, available for the adopters of Traefik to grow and expand as your business grows. Now, you may not need middleware to handle compression today because you're not serving JavaScript pages or static HTML, or you may not need to limit the number of simultaneous connections or custom error pages. But the chances are that in the future, as your platform, as your business grows, and as your needs change, those things are going to be there for you in the future. Now, this is sort of a rhetorical question, but does anyone here like managing SSL certificates? I don't think I've ever met anyone who enjoyed managing SSL certificates, myself included. Now, and that's why Traefik Enterprise offers the ability to provision SSL certificates on the fly using Let's Encrypt. Furthermore, Traefik Enterprise ensures that those certificates are up to date and highly available through its distributed key value store. Now, and for instance, if you do want to manage your own SSL certs, we have that covered as well, as Traefik can easily be configured to serve certificates that you define, again, all without downtime. You can apply those certificates, do the rolling update, and those certificates will be available. And finally, what we believe is critical for users of cloud native systems today is the ability to migrate to other platforms, whether it be Kubernetes, Nomad, Mesos, or anything else, without having to change how you manage and configure access to your applications and services. This is done because the configuration schema for Traefik is the same for routes, for middleware, for security, across all of these different platforms, and that enables you to migrate between them at will. And you can do so by retaining all the same configuration arguments that you're using in one platform versus another. Now, before we get started with the demo, I'm going to hand it back over to Adrian to discuss how the Traefik Enterprise architecture ensures both scalability and availability. Now, over to you, Adrian.
Okay, thank you, Kevin. And also just bouncing on your last comment. So exactly, Traefik is platform agnostic. So it is made for other, orchestrators, but also if you would like to install Traefik on VMs or bare metal, it is possible. You can, do a file installation, as we call it internally. So it is made for containers, but fitting also some other more classical use cases. So quickly presenting you the Traefik enterprise architecture before we are jumping on the demo. So as you can see, Traefik in the middle of the screen is a cluster. So it's basically a clustered version based on Traefik Community Edition. And so we have this notion of controllers versus proxy. So we have this separation of concern in order to have only the controllers talking to the swarm or to the Docker socket, in order to understand what are the events or all the different characteristics from a certain cluster, and then the controllers are able to share all the different routes, services, all the guidelines, let's say, to all the proxies, so the proxies can route the request from the internet to your infrastructure. And whenever you would like to scale in the future, let's say you have more requests per second to handle, you have more and more services on Swarm and on Kubernetes, and then you are only scaling horizontally the number of proxies. So with this distributed architecture, you have high availability, scalability, and more security also, because the proxies and the controllers are discussing between each other through a gRPC encrypted communication, what you see on the dotted lines here. And it brings distributed features on top of it, such as the distributed Let's Encrypt. That's the ability for the Traefik cluster to discuss with Let's Encrypt in order to validate your certificates. And then all the proxies are aware, constantly whether a certificate is valid or not. And you don't need, as Kevin was saying, you don't need to maintain an external, solution such as Cert Manager, Certbot, or a KV store to do that. It's all embedded in Traefik Enterprise. On top of that, we have some distributed middlewares. For example, and especially I'd like to mention the one regarding the authentication that you've seen on the slide before. So we have a middleware with you can delegate the authentication to the Traefik Enterprise proxy by leveraging an LDAP repository, JWT, JWK, HMAC, OAuth, and OpenID Connect. Because the good news is, yesterday night we've just released Traefik Enterprise 2.2, which is covering now, including also OpenID Connect, and also, by the way, we have a service mesh available inside this Traefik Enterprise 2.2, but only for Kubernetes regarding the service mesh. So that's the architecture of Traefik Enterprise, and Traefik EE is also shipped with a command line that we call tcudl internally, and that's a good segue to you, Michael, in order to start the demo and show us how you can use the cudl to do the installation of the cluster.
Sure, thank you very much. So I will share my screen. So yeah, so during this demo, we will handle 5 points. So I will show you how to install Traefik Enterprise into a Docker enterprise cluster without the use of the Docker socket. So it will be only possible with the Docker Enterprise version because there are the notion of UCP, the Universal Control Plane. So I will show you how it works. And I will continue with the exposition of 2 applications, one running on Swarm and the other one running on Kubernetes. And I will show you that you can access independently to each application, and we can create a rule on top of that to be able to do a canary things, to be able to have 50% of the traffic on the application on Swarm and 50% of traffic on the application on Kubernetes. And I will continue by creating some middlewares to protect my application with a distributed rate limiting and also an integration with the authentication with OpenIP Connect. And finally, I will finish my demo with the way we are collecting logs to have some metrics. So, okay, so today I have installed a Docker Enterprise cluster into AWS. So this is the architecture we will have. So we have a free manager node, Docker EE manager node, and we will have 2 Swarm workers only for Swarm and 2 Docker EE workers only for Kubernetes. In front of these 2 Swarm workers, we will have a network load balancer on AWS, and we will just reach this network load balancer, and the request will be forwarded to Traefik on it. So as you can see, I have my Docker Enterprise version here. I can sign in, and I will show you that we have some nodes available. We have 3 managers, 2 workers for Swarm here and here, and 2 workers for Kubernetes here and here. Okay, so I have an access to my cluster with my command line Docker node ls, and as you can see, I am using one of the latest version of Docker Enterprise. So to install Traefik Enterprise, we will proceed with the CLI, and we will install Traefik Enterprise only on the Swarm worker. So that means the controller and the proxies will all run on the Swarm workers. No workload will be on the manager at all, because we will be able to use the UCP to create a communication through this UCP to avoid to have the controller running on the manager. So to do that, we will first of all use the TCTL -f. As you can see, we can have multiple commands to install and to operate day-to-day the cluster. So first of all, we will set up the installation. To set up this installation, we will use the first command, that is this command. So I will not run it because I already ran it on my laptop a few minutes ago, but the idea is to point to the Swarm host. So on my side, I have not a VPN to my my cluster, so it's the public IP, and I'm allowed to access through specific ports to this public IP. So this is all the IPs of my manager nodes. I will continue with a second command that will generate the YAML stack for the installation of the controllers. So I can run this command, and I will show you this command, the generated file. Okay. So as you can see here, we have a compose file that is used to install the product. We are using the latest official Docker image, Traefik v2.2. There are some parameters, some option to launch the controller, and we have also an API proxies running on these ports that will allow me to communicate with the controllers with my TCTL command. And I will also generate the proxy stack command with this command. And I will show you this proxies command. And as you can see here, we have the stack for the installation about the proxies. So there are some information. So everything is configured for the installation, and the controller will start, and the proxies will be able to join the cluster. So I will just have to apply these 2 files. First of all, I have to deploy and install the controller stack. Here you can find on my Swarm things, the services. So I have already installed all of my monitoring things. So as you can see here, I have my new services arriving, the Traefik API, and I will have my controller here. So it's just starting. Docker service logs. Excuse me. So I will have to delete my stack. So because I have an issue, delete stack rm Traefik key docker config ls. There we go. Okay, docker. I think I have an issue with my volumes. I will just check volume ls. So I think this volume is an issue. Sorry about that. Stack rm Traefik key. I will deploy stack deploy, and it should be good in a minute, in a second. Okay, Docker service ls. So as you can see, I have my Traefik key proxies running here, and I have my controller running. So now everything is running. I can deploy my proxies very easily. I just have to deploy my stack. So it will create the two proxies. And as you can see, my proxies are listening on port 8080 and 8443 for the TCP. So now to check that my cluster is running correctly, I can use my tctl command to execute some command on my cluster. So with tctl, you can manage multiple clusters. So here it's like a context. So I will tell to my tctl that I will execute all the commands on the cluster named webinar. Okay, and now I can execute some command, get nodes, for example. So and as you can see, I can retrieve the nodes. So now I have my cluster installed. So I have to deploy some configuration to tell to my proxy to listen on the port 80 and 443, to listen the Docker provider, the Kubernetes provider, and to enable some other stuff like the metrics, etc. So to do that, I will apply a static configuration. This static configuration is here. So as you can see, I am creating some entry points to tell to the proxies on which port they have to listen on. I will create a global redirection to tell to my proxy for each request arriving on the port 80, they have to be redirect to the entry point web secure with the schema HTTPS, and the web secure entry point is on port 443. I will enable my dashboard. For now, I will keep this provider, this two-line comment. I will show you after how it can be used. I will listen on the Docker provider, and as you can see, I will hand over to the ucp.webinar.dockery.containers.cloud on the port 443, and I will use some certificates to create a mutual TLS authentication between my controller and UCP to be able to run my controller onto the worker nodes, Swarm worker nodes. With these 3 lines of configuration, this is a very interesting feature, is the network discovery. So that means that for each application that will be deployed in your Swarm with a new network, Traefik key will be able to detect this new network and to attach the proxies to this network to be able to send some traffic on it. I will enable the metrics with Prometheus with these 2 lines. Here, with the certificate resolver, I will be able to manage all of my TLS certificates with Let's Encrypt. And as you can see, I am using the TLS challenge for my demo. If you have your own certificates, it is totally possible to use the TCTL to import your certificate into the cluster, and Traefik Enterprise will be able to use your own certificates. With the outsource just here, I just referenced my OpenID application on Google. So I have my client ID and my client secret. So I just have now to apply this static configuration. So to show you that there is no static configuration applied, I can do SC for static configuration. The configuration is empty. I will apply my toml file, static.toml, and now the configuration is applied. So that means the controller is able to start to listen to the provider and to send the information to the proxies. Okay, to show that everything works well, we will access to the dashboard. To access to this dashboard, we will we will use a new thing in Traefik Enterprise. It's the Traefik configuration. So the Traefik configuration allow you to apply some static file like this one. Oh, sorry, like this one to the cluster with the TCTL. So I will create a simple router for the dashboard and say, okay, if the request arrive on with the hostname dashboard.webinar.containers.tech, so I will expose API at internal. This service is an internal service in Traefik that is used to expose the dashboard. With the line 6 and 7, I will enable the TLS on this router, and I will use the cert resolver, LE resolver, to generate my TLS certificate. So to apply this file, it's exactly the same command as before, tctl apply -- file and the file. Here, I have exposed my application, and I will be able to access to this application. So I can just copy this URL here and try to access to this application. And here we go. As you can see, I have a valid certificate. I am on the HTTPS, and I have a certificate that has been generated a few minutes ago. And this certificate is valid until the 20th of October. So this is the Traefik dashboard. Here, there is an overview to let you know how many nodes you have in your cluster. So it's a single dashboard for all of your clusters. So that means you scale up or down your proxies, you will have the information here. So you can retrieve the information about the controllers and the proxies ingresses here. And the interesting part is here. So with this dashboard, you can see that you can manage you can not manage, but you can see, because today the dashboard is only on read-only. You can see the HTTP routing, the TCP routing, and the UDP routing. So during my demo, I will be focused on the HTTP part. But keep in mind that if you have some TCP and UDP routing, you can totally use Traefik Enterprise to manage this part. So on the HTTP routing, there are three important things: the routers, the middlewares, and the service. So the routers are used to define the rule you want to have to access to a specific application. The middleware have been introduced to be able to customize, to tweak the request before sending it to the service. The service is, I can maybe show you this one because I have already installed my stack. The service is the list of servers for your application. On my side, I have installed Grafana here, so I have only one replica. This is why I have only one URL. Okay. So now I will deploy an application. So to deploy this application, I will deploy this application onto my Swarm worker. And this application will be the Hub v1. So something pretty classic. So I will deploy a stack. So it will be a simple stack with a demo application. So as you can see here, I am creating a new network for my application. So here it will create a network, my network. I am referencing my image. I am putting some comments, some arguments for the start. I ask to have 5 replica, and I will add some labels. These labels will be detected by the controllers, and these controllers will be able to create dynamically the routing. So that means that, for example, a request arrived on app.webinar.containers.tech, and the path is v1. So the request will be forwarded to this application. So this is the meaning of this slide here. Here we are just telling that we are only accessible on the port 443 on the web secure. Here I will ask to have a valid certificate for this application. So that means that the controller will be able to generate for me certificates through Let's Encrypt for the domain app.webinar.containers.tech. And I will just have to specify that the proxy will have to use the My Network overlay network to be able to access to this application. Okay, so I will just have to deploy this application with this command. And here, in few seconds, you will see the application arriving here in my dashboard. So it can take around 10 minutes because today we need to use a polling on the UCP controller. So this is why it can take few seconds. So here, as you can see, I have my new application available. We can retrieve all the information about this application. The application is accessible only on the port 443. The router will be app_v1 at Docker. The host will be this one. And I will forward the traffic to app_v1. Here, we can see that I will do a load balancing between all of these three services. So if I try to access to this application, so I will retrieve this URL. Okay. So if I go here, I will have a 4 or 4 because no routes are available to access to this application. But as you can see, I have already a valid certificate. But if I access with a specific path, v1, now I'm able to access to my application running on Swarm, app_v1 on Swarm. And if I refresh the page, there is a load balancing between all of my pods, my container. Okay, pretty simple. So now we will install an application on Kubernetes. And this application will be detected by Traefik Enterprise and will be exposed to the outside world through my network load balancer with Traefik. So to do that, I have two things to do. So you remember at the beginning that I have two lines commented on my YAML file, my static YAML file. It will be a cat.traefik.static.toml. So I have just uncommented these two lines here. And I will just tell to the controller to also listen on the Kubernetes CRD and use this endpoint to access. I have introduced all of my credentials already in my controller to avoid to do it during the demo. But you will use some specific credential to access to UCP for the Kubernetes CRD part. So we have introduced with Kubernetes the Kubernetes CRD, but we are also compatible with the native ingress object of Kubernetes. So I have updated this file. I have to apply this file onto my cluster. So to do it, I will use the command tctl apply -- file traefik static.toml. So I will apply this new configuration into my cluster. There we go. Now everything is applied. Now I will have to deploy a new application. So to deploy this new application, I will apply a YAML file for an installation in Kubernetes. So I will create a namespace. I will create a deployment. This is the way we are creating a number of replica of an application. I will create a service to be able to access to my application. So as you can see, the name of my application will be app_v2 on K8s. And I will also create an ingress route. This ingress route is the same as the label. So it's exactly the same concept, but it's writing in another way. So you have to define your ingress route to be able to access your application in Kubernetes. So I just have, so it's exactly the same. So it will be app.webinar.containers.tech. And if the path is v2, I will be forward to the v2 application. And I will also generate a certificate for this in case of the certificate is not generated. So I will do a kubectl apply -f the kube.yaml. And here it will create, oh, I think I will have an issue. No, everything is okay. I have already my CRD created. So, and here you will see the application arriving in 2 seconds. And here, this is my application. So I have my application available on app. So it will be the same. It will be the same URL with v2. Okay. And here we go. I am on my application running on Kubernetes right now. So as you can see, I have another range of IP. And if I refresh, I have a load balancing between my 2 pods running in Kubernetes. I can show you with get pods minus n apps. No, it's not apps. Cat cube. I don't remember the namespace. It's app. Get pods minus n app. No. There we go. So as you can see, I have my 2 pods running here. So now we will try to do a canary deployment between these 2 applications. So that means that I will create a new router, and to create this new router, I will use my dynamic file. So if I refresh the page, Traefik dynamic.toml. Here, as you can see, I have the router for my dashboard, and I will create a new router. This new router will be a router of type only host, so with no path on it, and it will just say, okay, if the request arrive on app.webinar.containers.tech/, I will forward this request to the service app. This service app will be of a type like that. So I'm just updating the file on another screen, and here. So I have just had the service app, so HTTP services app, and I am referencing. I am creating 2 services of type wait, and I will reference the app v1. So the app v1 is the one available here. Okay. And I will have to update. I take this one because it's not the correct one. And okay. And here I will now do a load balancing with 50% of my requests on Docker and 50% of my requests on Kubernetes. So here I will show you the final file. It will be this one. So I will send 50% of my requests on app v1 at Docker, and the other 50% to app TLS, this random number at Kubernetes. Okay, I just have to apply this dynamic file like that. Here you will see in a second a new router. So this is this one. Okay, here as you can see, this is a specific router for this load balancing. And now if I access to app.webinar.containers.tech, the first request is on Swarm, the second one is on Kubernetes, the second one is on Swarm and Kubernetes. And I have a load balancing of 50% and 50% on my Swarm and Kubernetes. Now, if I decide to say, okay, no, I want all of my requests running on Kubernetes, it's pretty simple. So I just have to update my dynamic.toml file here. And as you can see, I have put 100% of my requests on Kubernetes and 0% on Docker. I just have to reapply this file with this command. And here we go. Everything is on Swarm without any restart. So automatically, Traefik Enterprise has detected this new change and is able to route the full traffic on my Kubernetes. If for any reason I want to roll back to have 50 to 50, it's pretty simple. I just have to change my number again, and 50 and 50. I will apply again, and here we go. Now I have one request on Swarm, one request on Kubernetes. So if you are able to do it, now you will probably want to secure your application. So to secure your application, the notion of middleware will be introduced. So first of all, let's say we want to create some rate limiting. So to create some rate limiting, it's pretty simple. So I will continue to update my dynamic.toml file here. So as you can see here, I have created middleware. So I will have probably an issue because I have, no, it will be okay. So I will create a middleware. So this middleware will be, the name will be rate limit. It will be a type of rate limit. I will tell to this middleware to have an average of requests of 2 requests per second and to have a burst of 2 requests per second. So if I create this middleware, you will see this middleware arriving here. So I will apply my file again, and here we go. I have my middleware available. So to use this middleware into your application, it's pretty simple too. You just have to reference this middleware. Right limit. There we go. As you can see, I have referenced my middleware with this line middleware's right limit. And if I apply the file again, I will be able to have my application with the middleware, and it will be this one. And here I have the right limit available. Okay, now if I refresh the page, so I am blocked because I have done too many requests. And finally, to be able to secure your application, you will probably want to add some authentication mechanism. And to do that, it will be in the same way. So you will have to create another middleware with the OpenID, with some properties. You can easily reference this middleware, for example, on your dashboard to say, okay, I want to secure my dashboard. It's the name of the middleware is OIDC. Here, I have created this line, middleware OIDC, and I apply this file. And now I will need some authentication to access to my dashboard. So if I refresh the page, now I have to log in. So I will say Michael at Containo. Oh, sorry, it's Michael at containo.us. There we go. So my password is this one. I click on next. So I have to validate on my phone. I click on my phone, and there we go. I'm able to access to my dashboard. So I have some issue with my nodes anyway. And now I need some authentication on my nodes. Finally, during this demo, we have so that we are able to collect some metrics. And I can go here and here. Here we go. And during the last 30 minutes, during my demo, I have to do some request, and you can retrieve all of this request onto your Grafana dashboard. So the things you have to keep in mind that is with Traefik Enterprise, you can easily be able to route some traffic for your Swarm worker nodes or your Kubernetes worker nodes very easily by doing some canary deployment with rate limiting and OpenID Connect. So I'm handing over to my colleague Kevin to summarize the webinar. Thank you very much.
So thank you again, Michael, for giving us that in-depth demonstration of how Traefik Enterprise will work with both Swarm and Kubernetes at the same time and allow you to apply advanced routing capabilities like, as you saw in the demo, canary testing. So just to wrap up real quick, we have several questions that have come in, and we probably won't have time to get to all of them. Rest assured that if we don't get to your question, either Adrian or Michael will follow up with you after the webinar. So just a quick wrap up, Traefik Enterprise, we see that it does give operators those high availability and those features that they need out of a load balancer right out of the box, that the approach to configuration and the management options available to operators are both flexible and powerful, and they're available through either the CLI interface or through the dashboard. And that is fulfilling our goal of being simple to use. We also saw how we unlock the ability to do canary deployments and more with Traefik Enterprise, knowing that when it's time to migrate to another orchestrator, that your work is going to migrate with you. And also, for anyone who registered for this webinar, you will receive the recording in a few days. We're also going to include a free trial to Traefik Enterprise Edition. And if you have any other questions, please feel free to reach out to any of us. And if you're just so excited that you can't wait to try a free trial of Traefik Enterprise. Adrian's going to put a link of that in the chat as well. So with that, I'll hand it over to Adrian to field some of these questions. And thank you again for y'all's time and attention.
All right. Thank you, Kevin and Michael. So let's take a few questions. For example, Daniel is asking some questions. Are both Windows and Linux containers supported? Michael, you would like to take this question?
So sure. So today with Traefik, Traefik Enterprise is developed in both. So we are building some binary with 4 different architecture, and today we are only building the container for Linux, but we have planned to have the containers for Windows soon.
But you can do the installation on Windows or also on VMs. It is supporting both, right?
Yeah.
Okay. All right. Another question: is it possible to put some airbag on the web portal, like namespace based? So only namespace A can see routes from namespace A.
So you will not be apply airbag like that, but you can tell to Traefik Enterprise to listen on specific namespaces only. So we are not fully integrated with the airbag things for the display of the dashboard.
Okay, thank you very much, Michael. Let's take another question. Would you rather recommend using Docker secrets than Docker config for providing SSL certificates on the TOML files to the Traefik service, or no difference? I don't know,
So,
Kevin or Michael, if you would like to take it.
I am trying to find the question. So
it's at the top.
Recommend using Docker secret. Docker secret or Docker config for providing SSL certificates and the TOML files to the Traefik services. So today with Traefik Enterprise, the way it works is you have to use the TCTL to be able to import your certificate if you are your own certificate, and the certificate will be not managed by Docker. It will be managed by Traefik Enterprise.
All right. Let's take another final question before we are stopping the webinar. Which one can we take? Yeah, does this cluster swarm network discovery facility is also available in Traefik Community Edition?
So the answer is no, it's only available on the enterprise version.
But related to
because because I will give more technical information on it. It's because the way we are designing things, the controller has been put not on the proxy side. So that means that the controller detects that a new network has been created, and it will do a rolling update of the proxies to be able to connect the container to the proxies automatically. And this is why it is not possible with the open source version. It's because Traefik cannot tell to himself to just kill himself to attach to go to a new network. So it is not possible.
All right. Thank you very much, Michael. So don't worry, we have plenty of other questions lining up. We will take those questions and answer them separately. So again, thank you very much for attending this webinar. Feel free to check the free trial of Traefik Enterprise. I have added the link into the chat section, but we'll make sure also to send that to you. So free trial, that's good. The recording, and I think we're good for today. So again, thanks Michael, thanks Kevin, and wishing you all a very good day, afternoon, or evening. Bye-bye. Thank you.
Bye-bye, everyone. Thank you.